Good morning, friends. In today's video, we are going to solve a numerical example on the design of shaft, wherein the material of the shaft is given and what power is to be transmitted is also given. Friends, here the question runs like this. A C45 shaft is required to transmit 20 kilowatts at 1000 rpm. Determine the necessary standard diameter of the shaft required based on factor of safety is equal to 3. Friends, this is the clear indication wherein the shaft is subjected to only torsion. So you can have it as a small clue. Whenever in any of the design of machine elements, whether it's a shaft, key, coupling, clutches, bearings, gears, whatever it may be, whenever you have this term power in kilowatts and RPM, this clearly indicates that the shaft is subjected to torque or torsion or twisting moment. Hence, you will be able to find out what is the torque transmitted based on these two parameters. Friends, no other information is given here. So, it is a problem on a shaft subjected to only torque. And hence, based on the maximum shear stress theory, the diameter of the solid shaft is given by diameter D is equal to 60 over pi into tau Vd kT mt, whole thing to the power of 1 by 3. Friends, we already used this equation in one of our previous videos. That's on shaft number 2. That is question number 1 I used. Friends, what are these values? So friends, here you can see this kT is equal to the shock factor, which is generally taken as 1, assuming a steady load. Next comes tau Vd. Friends, tau Vd is the design shear stress that is to be found out. So, in the questions, the value of the shear stress may be given, or sometimes they specify the material to be used, like this AC45 steel, or sometimes they ask you to select the material and obtain the corresponding value of this tau Vd. Here, friends, the material given is C45. This C45 is also called as 45C8. 45C8. It is a carbon steel having average 4.5% carbon in it. So friends, if you refer to machine design data handbook on the materials that are used for the shaft, for the C45 material, for C45 material, we have what is called the sigma ut, means ultimate tensile strength of the material, which generally runs from 618 to 696 Newton per mm square. This is available in the machine design data handbook. So you can take either the smaller value, higher value, or any value in between. So I have taken sigma ut is equal to 618 Newton per mm square. So from this value of sigma ut, I should be able to get the value of this tau Vd, the design shear stress. Friends, now this sigma ut is given as, or sigma u is 618. So from this, I am going to obtain the yield value, that is sigma y, based on this is generally taken 0.5 times sigma ut. So these are very important in design. So this will be 0.5 multiplied by 618, that works out to 309 Newton per mm square is the value of the sigma y. From sigma y, I have to obtain what is tau y because I need tau vd. Now we can write down this tau y is equal to zero point 0.6 times sigma y. This is an assumption. This is how these two are related. So this is 0.6 times the value of 309 is sigma y. So this works out to 185.4 Newton per mm square. This tau y is the yield shear stress, but we are not interested in yield shear stress. We want design shear stress or permissible shear stress. So this tau vd, the design shear stress, is equal to the yield value divided by FOS. FOS is factor of safety. So this is 185.4 divided by factor of safety is 3. So this works out to 3 6 are 18, 3 1s are 3 to 61.8 Newton per mm square. Friends, we have all the values required to get the value of D. We know KT, we know MT. MT, let's find out because they have given the power. And tau vd we have already obtained based on the material. Friends, how to obtain this? MT, the torque required. Friends, the torque required is obtained from the formula torque MT is equal to 9550 times N divided by N into 10 to the power of 3 Newton millimeter. And this is the equation once again available in the data handbook, where this N stands for the power transmitted, the power to be transmitted, that is 20 kilowatts, and N is the speed of rotation of the shaft in RPM, that is given as 1000. Friends, if you make this substitution in the formula, you will be able to get the value of torque. So this works out to 9550 into power is 20 multiplied by 10 to the power of 3 divided by 1000. Friends, if you simplify, you get this value as 238780 Newton millimeter. So we have the value of KT1, MT you have calculated, tau vd is 61.8 and pi is a constant. If you make this substitution in this formula, friends, you will be able to obtain D, the diameter of the solid shaft required. So friends, let us substitute. So D is equal to 16 divided by pi multiplied by tau vd is 61.8. Just now we have calculated. Multiplied by KT is 1. This MT is 238780 Newton millimeter. The whole thing rise to the power of 1 by 3. And if you simplify this quantity on the right side using the calculator, you get the value of D equal to 26.99 millimeter. So this is the minimum diameter of the shaft required to transmit 20 kilowatts at this RPM. Friends, as designers, you are not going to keep the value as 26.99 whether they ask in the question or not. You should always go in for a standard size. Friends, the standard size available here after this 26.99 or nearest to this is D is equal to 30 mm. So this is the standard size of the shaft required to transmit 20 kilowatts at 1000 RPM. Friends, if you are happy with the presentation made by me, do subscribe to my channel in case if you have not done so far, and share this information with all your friends, and have a wonderful day.